Assuming that g orbitals feel according to the Hund's rule, what is the atomic number of the first element to have a field g orbital? Okay, so we're talking about electron configuration, but we're not talking about the electron configuration of any element that we have on the periodic table, because we know at this point we don't have any element that occupies the imaginary g orbital. Remember, S, P, D, F are the only ones that we have in use currently on periodic table. There are no G. But let's assume. Now we can always dream that we can find more elements or eventually make more elements along the periodic table, and if everything that we did was following the Hund's rule, now what would it be like to have a field g orbital? What element number that would be? Okay, so how do we do that? Now we know that following the Hund's rule, your electrons goes into the orbitals now based on energy level. So one by one the electrons goes in and eventually fill one up and move on to the next one. We do have a simple scheme to figure out which one fills up first. Let's draw that a little bit. Starting from the first shell, we only have one S. That's always the first one to be filled. 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F, 5S, 5P, 5D, 5F, 5G. Here we go. This is the one that we're trying to fill up. The first element to have a filled g orbital. Now, when we filled orbital, when we got here and filled all the way up, we would be good. But again, the electrons doesn't fill the orbitals according to the shell numbers. It has a more complicated way. So let's keep going. 6S, 6P, 6D, 6F, 6G, 6, well, let's call it H. 7S, 7P, 7D, 7F, 7G, 7H, 7, well, whatever. 8S, P, 8D, F. This should be enough. Alright, the way that we use this diagram to determine the order of energy level is that we draw diagonal arrows one after another. And eventually we get to 5G. All the orbital designations getting crossed by the arrow are filled. All the ones not touched by the arrow, well, would be empty. So once we got here, we would have the first element that has a filled g orbital. Now let's just count the total number of electrons that we used. Alright, first shell, just 2. Second shell, 2 plus 6, 8. Second shell, 2 plus 6 plus 10, 18. Fourth shell, 2 plus 6 plus 10 plus 14, 32. Fifth shell, 32 from S to F, and then 18 more on G, 50. All these are filled. Every single orbital of the shell. And then 6, 7, and 8 are all partially filled. So let's see how many electrons we need to put there before we get to 5G. 6s is filled, that's 2. 6p is filled, that's 6. 6d is filled, that's 10. So it's a total of 18 electrons. 7s is filled, 7p is filled, total of 8 electrons. 8s is filled, 2 more electrons. Alright, so these are all the electrons that we need to fill the orbitals up all the way to the first G orbital, 5G. And whoever that element is, doesn't have a name now because it doesn't exist. But if everything follows Hund's rule, then when we get there, this should be the total number of electrons in the neutral atom. This should be also the atomic number. So adding them all up, you get 138 electrons, and that means the Z of the neutral atom equals to 138. So element number 138 would be the first one to have a filled G orbital, now, if it exists, and if the electrons do fill according to our Hall principle and Hund's rule.